So we given this bunch of numbers, so obviously we're going to add all of them in. So got 4, got 5, got 8, got 2, and then I mean obviously we're just going to add all of them in, the 4, the 5, the 8, the 2. Now like the question, like the rule book that they actually give us, the number is this 3. So that means I want, like, maybe say if I were to actually call it, is that they want the third largest value. And not only that, they basically they only their main concern is getting this. So now like within all these numbers, like which one is like the third largest, like intuitively, I mean we can tell it's already this number, right? So now, and what does like the min heap does, like one of like the property is just basically take the minimum value. So if we were to see, is that if I'm able to actually remove like the min heap value, for this case is a 2, what you actually realize is that among these numbers we are actually getting like our third largest value in our min heap. Like the like when I actually look at it, it's like, you remember like how stack works, is that they will always like look at like the first value. So I mean for a stack wise, it's like the last value, right? But for this case, I mean it's like the min stack, min heap, right? So what a min heap does, right, is that on top of the value, right, like basically the last value, right, like this guy, right, is actually the minimum value, and it's also known as like the last guy over here. So what I'm trying to actually say is that, like, the moment like we among these guys, right, what we are interested is that we want to know like the third largest value. By removing 2, right, now we put the this last guy to be the guy that we are very much interested with, which is like the third largest value. So like among these 4 values, whatever we are interested in is the number 4, and whatever we try to actually achieve here is that there's 4 guys, right? We need to remove the last guy. It's not to say that we don't need the last guy, it's just that this last guy, while applying we are trying to place the last guy over here to be what the rulebook is asking us for, which is the third largest. So by removing these 2, we are placing, our main priority is to place this third guy to be over here, and we are able to actually achieve that if we remove this. So now, like, maybe say for example, okay, cool, now I'm gonna tell you that, okay, now cool, now I'm gonna actually place the 3 over here. Fine. So now, like, let's try to play it out. Like, among the 4 guys, who are we gonna remove within like the min heap? Given that like k equals to 3, that means that our this box, right, we only can actually store 3 values. That's also one of the rule. So I mean, we have 4 values here. Obviously we need to remove 1 guy, bro. And who is under the min? Is actually this number 3, and this 3 guy is out. And then now we suddenly place the last guy to be the 4 again, and among And let's intuitively ask, among these four, like which guy is actually the third largest? It's the 4 again. It's the 4 again, right? So here's the thing is that whatever we are doing over here is favoring towards like making sure that we get the third largest value. And we always make sure that we have like only 3 values. By doing that, right, we are trying to favor to actually let our third largest guy to be always on top. We want that guy to be on top so that we can actually bring it out to actually send back to the system, because the system is so interested in getting that value. And yeah, and I think that they actually did mention very briefly, which is a very concerning one, which is that why not we actually just use a normal array to actually try to actually solve the problem. So they didn't play it out, and they obviously drew it out over here, very vague, never play it out. So I'm gonna give it a try and see how it actually pans out, right? So maybe say I'm given this bunch of values. I want the third largest value from here. How am I gonna do it? I think first and foremost I will do a sorting. I'll sort these guys out first. So, and then after sorting, I will actually say that I will collect the whatever index that is like equals to say 2, which is for this case is getting like the third value. So I mean this whole operation for sorting is a n log n for sure. Getting this index, is it n? I think I don't know. Yeah, this is how I'm gonna do it. And I mean like if we were to call it that this one is like operation z, and whatever we've done so far is like operation y, whatever they are actually trying to actually imply is that operation y is much more efficient than operation z. This z is like an unknown step that I don't know so far. But if I were to actually call it is that brute force always want to fight against the main character, right? That's how I actually argue how brute force is going to fight the main character. And in this case, the main character for today is to do with like hippie-fi, right? And hippie-fi for this case we are doing the minimum hippie-fi amongst the characters. So obviously when we actually see this whole thing, we did already can tell that whatever the rulebook is trying to ask is that it's very much interested in like the third largest value, right? That's what it care about, that the value that you want to actually send back the system. And obviously we introduced this whole algorithm of having this min heap where we first and foremost we try to actually box out the 3 values, right? So and very much so is that we just really at the core of things, right, is that we actually am abusing this uh, min heap, so to speak, right? Is that okay? We are being thrown with like this bunch of numbers, and then we just box it out into 3 items, and then on we make sure like the top guy, right, is the guy that the system wants. That's what we've been doing so far, and whatever we've been doing, it's really come down to like um the basic spell of, say, like the min heap. That's all we are actually abusing, and whatever like the value that we actually plug into, we just make sure the parameter that we actually throw into this guy over here, right, is that we make sure is like whatever the rulebook is asking us, based on what the rulebook is asking us, and for this case is a value 3. And with that, right, just based on that, right, we can throw the top guy to be the one of what the system wants and throw it back to the system. And that's basically all the things that we've been doing so far all this while. And I mean, obviously this bad boy here is a spell that we've been casted so far. So yep, with that everything comes to an end.